So we're going to take a look at module 2B in this video. So for question 8, we are graphing those two quadratics, and in each of them we have to identify what the vertex is. So taking a look at letter A, that one is written in vertex form, which makes our job of finding the vertex really easy. So when we have something with the parentheses like this, we flip the inside, keep the outside the same. So my vertex is 1, 3. So now when I go to make my table, my XY table, I know that 1, 3 is going to go directly in the middle. I'm then going to pick 2 points less than and 2 points more than the vertex to plug in. So I'm going to start with -1. It's going to be -2 times -1 minus 1 squared plus 3, and that is going to give me -5. Because it's a reflection, I know that +3 must also go to -5 as well. And then I'm going to do the same thing with 0. When I plug 0 in, I would get 1, which would mean that 2 would go to 1 as well. Now we can graph it. -1, -5, 0, 1, our vertex 1, 3, and then the other two are reflections. We can see them in the table as well. So I'm going to go ahead and connect the dots, draw my arrows on the ends, and then we'll move on to letter B. All right, so now we're taking a look at 10B, which is graphing this quadratic in intercept form. So they give me the two x-intercepts for this quadratic, which are located at -3, 0, and 1, 0. And then I'm going to go ahead and graph those 2 points. My vertex then is directly between them. I know directly between them is -1. But then that's what I have to substitute back in to find the y value. So I'm going to draw my xy table. I'm going to put -1 directly in the center, and then I'm going to substitute that in. So -1 plus 3 and -1 minus 1. So that's like we're doing 2 times -2, which gives me -4. So I know my vertex then is down at -4. Now to help me out, I already know that -3 and 1 both go to 0. To make my graph a little bit more accurate, I'm going to plug in either 0 or -2. Those y values will be the same, and it'll help me see a better picture of what I'm looking at. So I'm going to plug in 0. So 0 plus 3, 0 minus 1 is 3 times -1, which is -3. So then I'm good to go ahead, plot those other points, sketch in what my graph should look like, and should look something like that. On to question 11, we are now solving each nonlinear system. We can solve it graphically or algebraically. First one, we're solving graphically since they provide me with that coordinate plane. So I'm going to graph the quadratic, graph the line, and then look for the point or points where they intersect. So let's go ahead and start with the line. That's always going to be the easier of the two to graph. My y-intercept is -2. My slope is +2, so up to right 1. I'm going to plot lots of points. The more accurate we can draw our graph, the easier it's going to be to see the exact point where they intersect. So I'm even going to shift this one over a little bit so it lines up. So now I'm going to go ahead and move over to the quadratic. So on the quadratic, I see that this one is in standard form. So if it's in standard form, step number 1, let me pick a new color. Step number 1 is to do opposite B over 2A. That gives me the x value of my vertex. So 2 divided by 2 times 1 gives me 1. So now when I go through and I make my xy table, 1 goes in the middle, and I can pick points that go around it. So now I'm going to go ahead and plug those in. While before, when we talked about systems and plugging in values, it didn't matter which one we plug it into, but if I'm graphing a quadratic, we have to plug it into the one that is a quadratic. So I'm definitely going to plug it into that top one. So when I go ahead and do that, I'm going to get 5, 2, 1, 2, and 5. So let's go ahead and graph it. And we can see that these graphs intersect in exactly one spot. So our options for a nonlinear system, the way that we do them, could be no solution, one solution, or two solutions. So we have one solution here. It is located at 2, 2. Moving on to question B, this one is solving this nonlinear system algebraically. We can see that both of our equations are set equal to y, so we're going to set them equal to each other. So we're going to have x squared minus x minus 6 equal to 2x minus 2. Before we can try to do anything, we have to get x by itself, or not x by itself, but we have to get all of this stuff over to the other side because we want this equal to 0. Because if we're solving something with x squareds and x's, we're probably going to factor, could potentially need to do quadratic formula. So I'm going to subtract 2x on both sides. I'm going to add 2. So we're left with x squared minus 3x minus 4 equals 0. This is 3 terms, so I'm going to go ahead and try to do x method on it. Negative 4 would be on top. Negative 3 would be on the bottom. Those two numbers are going to be 1 and negative 4. So x plus 1, x minus 4 equals 0. When I solve, it's like I set each factor equal to 0. These ones are pretty easy. We just flip. So x equals negative 1 and positive 4. When I go back over to part A, I wrote my answer as an ordered pair. This is not an ordered pair. These are the two x values. So we do have to plug them in to find y. So I'm going to start with the negative 1. Now it doesn't matter. You could pick either one to plug it into because we're not graphing. We're looking for the system. They should be the same. I'm going to pick the bottom one though. So y equals 2 times negative 1 minus 2. That gives me negative 4. So my first solution, negative 1, negative 4. I'm going to do the same thing with the other one. And again, I'm going to pick that bottom one. That gives me 6. My other solution then, 4, 6. So if I were to graph that quadratic in that line, they would intersect exactly at those two spots.